طلبة وطالبات شهادة الثانوية العامة قسم رياضيات لغات. السلام عليكم ورحمة الله وبركاته. اليوم سنتناول مراجعة عامة على مادة الاستاتيكا. عزيزي الطالب، طبعا المراجعة العامة لابد ان احنا نعرف قوانين مادة الاستاتيكا قبل دخول اي امتحان. طبعا مادة الاستاتيكا هي مادة احدى فروع المادة التطبيقية، بمعنى ان المادة التطبيقية بتتكون من الاستاتيك والديناميك. الاستاتيك 5 or 6 units. 6 units. The first unit is called friction. What about the rules of the friction? My dear student, you must observe the rules of friction and each units of a static. Welcome, my dear student, in our math program for secondary 3. Today we are taking general revision about static. Static subject contains 6 units. Friction, moment, about 2 dimensions, 3 dimensions, parallel forces, equilibrium, general equilibrium, couple, moment of couple, resultant of couple, and center of gravity. My dear student, look at about the first example about revision. Look at, my dear student, if the static friction coefficient between a mass of magnitude 20 kilogram and the ground surface equals 0.75. Static friction coefficient mu between a mass of magnitude 20 kilogram and the ground surface equals 0.75. The magnitude of the horizontal force which when act on this mass and make it about to move equals 12, 15, 16 or 20. Choose the correct answer. Before we choose the correct answer, my dear student, think and solve. Look at, in the opposite figure, we have body, its weight 20 kilogram weight, mass equal 20 kilogram, therefore weight 20 kilogram weight. N equals W, therefore N equals 20 kilogram weight. My dear student, we know that mu, static friction coefficient 0.75 or 3/4 from given. From the opposite figure, we know that B equal mu Sn. Mu Sn, mu S equals 0.75 times normal reaction. 20 answer is 15 kilogram weight. Then B equal mu Sn, therefore B or the force equals 15 kilogram weight. The correct answer, number B, 15. Another one. In the opposite figure, my dear student, AB is uniform rod, is about to move when the rod inclined angle theta to horizontal. If mu is the coefficient of friction between the rod and the ground, then choose the correct answer. Mu equal tan theta, mu equal cotan theta, mu equal half tan theta, mu equal half cotan theta. Before we choose the correct answer, look at the solution. In the opposite figure, my dear student, let AB equals to L. We haven't length of AB. We suppose AB equals to L. This length. BE, look at BE equals L cosine theta. Theta inclination angle between AB and the ground. Therefore, BE equal L cosine theta. Also, BC equal to L cosine theta. Remember, cosine adjacent of over hypotenuse. Cosine theta in triangle EBO equals EB over BO or BE over L. Also, cosine theta in triangle ABC equals BC over 2L. Then BC equal to L cosine theta and BE equals L cosine theta. AC, my dear student, equals to L sine theta. Why? Because AC is opposite angle theta. Therefore, by using the equation, R2 equals W. R1 mu R2. Therefore, R1 equal mu W. Moment at B equals 0. Therefore, by using W times BE minus R1 times AC equals 0. Therefore, W times L cosine theta minus R1 times 2L sine theta equals 0. Divided each term by L. Therefore, W cosine theta equals 2R sine theta. Therefore, we deduce that W cosine theta equals 2 mu W sine theta. Therefore, my dear student, cosine theta equals 2 mu sine theta. Divided each term by 2 sine theta to calculate mu. Therefore, mu equal cosine over 2 sine theta equal half cotangent theta. This example is very important. Mu, static friction force, equals 1 over 2 cotangent theta. Why? Because cotangent equal cosine over sine. Then mu equal half cotangent theta. The correct answer, number C, mu equal half cotangent theta. Now we are to translate the moment. What about the moment? We know that moment depends on two things. What is the two things? The norm of magnitude of the force, the distance between its line of action and the center of axis of rotation. The moment, we have two types of moment. Moment of 2 dimensions and moment of 3 dimensions. Don't forget, my dear student, moment depends on the norm of magnitude of the force and the distance between its line of action and the center of rotation. Look at, my dear student, moment of the vector respect to the moment is defined R cross F. Look at, in the opposite figure, what is the algebraic measure of moment of the force 100 Newton about the point A. Look at, my dear student, we can solve this example by mole method. As the first, moment about A, moment about point A. What is the force? The force 100 Newton. 100 Newton, we can find the distance between the point A and the action of the line of the force. Another solution, we can resolve 100 Newton about x-axis and y-axis. Why? Because inclination with x-axis with angle 40. Look at 100 Newton. Inclination or inclined with angle 40 with horizontal. We can resolve 100 Newton about 100 Newton cosine 40, 100 sine 40 in vertical, and find the moment by using the rule. Look at, we solve 100 into two forces, 100 cosine 40, 100 sine 40, horizontal, vertical. Moment about A, 100 sine 40, multiply distance between the action of the line of 100 sine 40 and the point A. What is the distance? 0.4. Remember, words of the distance mean perpendicular distance from A to the action of the force. Also, my dear student, 100 cosine 40 multiply distance 1.4, then don't forget we have two directions of the moment, positive anti-clockwise, negative with clockwise. Therefore, answer is 132.95 Newton meter. Remember, my dear student, unit of moment equal unit of the force multiply unit of the distance, Newton meter. Another example. Choose the correct answer. Look at, we have four figures. Number A, the force perpendicular from left. Number B, the force F perpendicular from right. The distance between, look at the distance between, or the first figure A, the force passes through point A. But the figure number B, the force perpendicular to L or perpendicular to the line and at a distance L from point A. The figure C, the force F inclination with acute angle theta. But the figure D, the angle or inclination angle is obtuse angle. Number A, the moment equals 0. Why? Because, excellent student, the action or line of the action of the force passes through the point A. This rule, any force passes through the point, the moment is equal 0. Number B, look at the moment equals F times L or L times F. Don't forget, my dear student, the moment about point equal distance times F, magnitude of the force multiply the distance L. Remember, theta equals 90. Theta equals 90. And we know that cosine 90 equals what? Equals 90. Cosine 90 equals 0, but sine 90 equals 1. Number C, moment about A, FL sine theta, smaller than number B. Why? Because theta is smaller than 90. Number D, FL sine theta and theta more than 90 degrees. Therefore, what is the greatest value? Is figure B. Why? Because in this case, the moment equals the magnitude of the force times L, F times L. Someone say why D is not correct. Because cosine theta is negative, cosine angle is obtuse, cosine in angle obtuse lie on the second quad is negative. Also, why C is wrong? Because cosine theta in the theta smaller than 90 is smaller than 1. Then we know sine 90 equals 1 in figure B, where in C and CD sine theta smaller than 1. The moment of the force about 3 dimensions. We know that if we have force in 3 dimensions act at a point x, y, z, position vector r vector, the moment r cross f, moment about O r vector cross f vector by using determine from the solid geometry IJK first row, x, y, z component of r, Fi, Fg, Fk components of the force F. The force F 2I minus j plus 3k at the point negative 3, 1, 2. Find the moment of the force F about B2 to negative 1. This example is very important example. Maybe this example we find it in choose the correct answer. It is easy to solve it. How to solve this example? My dear student, we know the moment of the force about 3 dimensions. We use determinant I, G, K, first row, second row, position vector R, third row, the force F. But we have AB. In this case, we find BA. BA vector equal A minus B. A minus B, negative 2 minus 2, negative 5, 1 minus 2, negative 1, 2 minus minus 1 equals 3. This is position vector R. After that, calculate the length of perpendicular from B to line F. We know that R vector equal BA vector equal A minus B equal negative 5, negative 1, 3. Therefore, moment about B, R cross F. R cross F by using determinant I, G, K in first row, second row negative 5, negative 1, 3, third row 2, negative 1, 3. Therefore, by using determinant, then the moment equals 21J plus 7K. We know that the length of perpendicular equal norm of moment over norm F by using square root equal square root 35. Now we are translate two parallel forces. This very important example, two parallel forces of magnitude 20 and F Newton act at the 2 points A and B. What is the required? The magnitude of the resultant 35 Newton act at the point C and AC equal 15 centimeter. What is the required? Length of AB equals what? Choose the correct answer. 15, 35, 45, 20. Look at my dear student, we have two forces, 20 and F, 35. This resultant of two parallel like forces. What you mean of like forces? Like forces, two forces in the same side. Look at the force at A, force at B. Two parallel forces in the same side. The resultant is 35. Then we know that the force F equals what? Equals 15. Why? Because 35 or R equal F1 plus F2. Resultant more than the given force. The two forces in same direction. We know that if the resultant more than the given, then the two forces like forces, parallel forces. The resultant between the two forces equals 35 equal F plus 20. Therefore, F equals 15. But we know that 20 times AC equal F times BC. Therefore, 20 times 15 equals F times BC. BC equals 20. Therefore, AB summation equal 35 centimeter. Now we are translate to another one. A, B, C, D, H are 5 points of the straight line where AB equal DH equal 20, BC equal 30 centimeter, CD equal 6 centimeter. Three forces of magnitude 15, 25, 35 Newton acts at A, C, and H. In same direction and perpendicular to AH, two forces of magnitude 20 and 30 Newton act at B and D in the opposite direction. to the set of the first force. Find the resultant of forces. Look at, in the opposite figure, we have 5 forces. 3 forces down, 2 forces up. What is the 3 forces down? 15 acts at A, 25 acts at C, 35 acts at H. Also, we have 2 forces acting up at B, 20 Newton, at D, 3 Newton. We know that to find the resultant in equilibrium, therefore forces up equal forces down. The resultant is R act at distance, we suppose R act at point O at distance x from the point A in direction of the greatest forces. Look at the forces down, 35 plus 25, 60 plus 15 equal 75. But the forces up, 20 plus 30 equal 50. Then the resultant of the forces must with the greatest force down. Therefore, R equals summation of the forces down minus summation of the forces up equals 25. This is the resultant of forces. After that, to calculate the value of x, we find the moment at A. Moment at A, by using the rule of the moment, how many points we have, how many forces which act, which has moment, has 5 forces. Don't forget, my dear student, forces up 20 and 30, negative 20 times distance 20 plus 25 times 50 minus 30 times 110 plus 35 times 100 equals 25x. What you mean? The moment of the forces about point A equal moment of the resultant about A. Moment of the resultant 25 times x. Then we calculate left hand side. We reduce that. 2100 equals 25x divided 25 each term. Therefore, x equal 84 centimeter. Then the resultant is equal 25 and at a distance 84 from the point A. This example, very important example, maybe find the value of x, maybe find the value of r by using the moment about the point A. Now we are translate to another example. In the opposite figure, if AB is a rod, rests in equilibrium horizontally, the distance x equal what? Choose the correct answer, 28, 14, 12, or 2. Look at, my dear student, the distance x. We have how many forces in the opposite figure? 6 Newton, 8 Newton, 10 Newton, and F. Acts at C. Moment at C, therefore, equals negative 10 times 4. Why negative? Because this clockwise. Plus 8 times x plus 6 times distance 2 plus x. The moment at C equals 0 to calculate the value of x. Negative 40 plus 8x, negative 12 plus 6x equals 0. We add like terms, 14x equals 28. Therefore, x equal 2 meter. The correct answer is 2. My dear student, in this case, the value or the length x equal 2 meter by using the moment at point C. Now we are translate to another one. In the opposite figure, AB is a rod. Rests in equilibrium horizontally, then distance x equals what? 5, 12, 10, 16. My dear student, we have the force F equal xi plus yj, the force which act at point B. 12 plus x, we have 12 plus x minus 16 equal the moment x equal 4 in this case. Therefore, 9 plus y minus 12 equals 0. We have two axes, horizontal and vertical. The forces in horizontal, 12 plus x negative 16 must be equal 0. Why? Because summation of the forces about x-axis equals 0. Also summation of y-axis equals 0. We deduce that x equals 4 and y equals what? Y equals 3. Therefore, f equals square root 3 power 2 plus 4 power 2 equals 5. Then the correct answer of the force F is 5. My dear student, by the end of the lesson, we know that the equilibrium and general equilibrium is very important lesson to solve how to find the value of resultant of the forces, moment of any force about any point. Don't forget the summation of moment about point equal moment of the resultant at the same point. My dear student, I am very happy to spend such time with you. Thank you. Goodbye.